you. Okay, so good evening, everyone. I'm so glad that everyone can join us for our third and final Golden Nuggets interview of the semester. We definitely look forward to continuing this interview series next semester. And to start as an introduction, I'm Nina. I'm a sophomore in geological engineering, and I'll be co-hosting this interview with Cassidy Grady. She also majored in geology and geological engineering. She's a recent Mines alum and soon to be graduate student at Mines. Our interviewee for today is Dr. Navarre-Sitchler. She is an associate professor within the Geology and Geological Engineering department. Her work involves aqueous geochemistry with a special focus on CO2 contamination of groundwater. She was also recently announced to be the newest Ben Freer Endowed Chair for Innovation and Excellence. This prestigious title includes funding for 3 years to further the vision and mission of Mines. So congrats on that accomplishment. And on that note, let's begin the interview. So Dr. Navarre-Sitchler, can you tell me about yourself and how did you get to where you are today?
Yeah, that's a great question. I grew up in Southeast Utah, so people who know the town of Moab and the surrounding area might not be surprised to hear that I'm a geologist now. So yeah, I grew up in a small town with parents who had not gone to college. I'm a first generation college student, so small high school, small town. And it came time to figure out what to do with my life after I graduated high school. I went to Mesa State College, as it was known back then, now Colorado Mesa University, because it was close, and they gave me a scholarship. And I started school as a business finance major because I thought that's how you became successful in life. I was going to be, an accountant or, someone that worked in business and finance until I got sort of 2 years in and decided that really wasn't what I wanted to do. And so I took what I call my Jeopardy semester. So I took a ton of classes across a wide range of topics, including things like Greek mythology and honors English. And one of the classes that I happened to take was Intro to Geology. And I took it at the same time that I was taking a chemistry class. And it all kind of clicked for me in a way that, I think was pretty fortuitous. And so I signed on to be a geology major, decided I was going to do geochemistry, and never really looked back. So I finished a bachelor's degree. Turns out there are too many credit hours, at which point they will no longer give you financial aid. And so they kind of shuttled me out the door and told me to go somewhere else and get another degree. So I actually ended up at Mines for a master's degree. So I did a master's degree at Mines in the geochemistry program, finished that up, had kind of a decision point in my life. I had a job offer at a very large oil and gas company in Houston, and had applied for a PhD program at Penn State and had gotten in. And so I ended up moving myself across the country to central Pennsylvania, getting a PhD, spent 5 years there pining for the Rocky Mountains. And so I wanted to come back. And so moved back west, did a postdoc at University of Wyoming, had stayed in contact with John McRae in the Civil and Environmental Engineering department. And when I got back this direction, we wrote a grant together that got funded that brought me to Mines as a postdoc. So I was at Mines as a postdoc for 2 years, and then was hired in the Geology and Geological Engineering department as faculty. So, and then now I'm faculty in Geology and Geological Engineering, and probably will be for a long time. So.
Awesome. So in all your work with geotechnical engineering and geochemistry, both in academia and in industry, what do you think is the most impactful work that you've done so far?
That's a good question. I don't know that I could point to any one piece of work that I've done, that I would say is most impactful. I think what has become the most impactful part of my work has really been working across disciplinary boundaries in a way that allows me to bring some creativity to the work that I do and think about problems in a new way. And so I think that the impact of the work that I'm doing is really, it's kind of spread across a lot of the stuff that my research group is doing right now in trying to, really look at how hydrology and geochemistry are connected to each other in natural systems and then in engineered systems. And so, really broadening, my expertise in a way that allows me to, to bridge that gap, and then, really being able to communicate across those boundaries and, bring expertise into addressing the problem. So I think it's less about any one individual, problem that is impactful, but more about the approach that I take.
So would you say, I mean, you couldn't really nail down one specific thing or like impactful work that you've done, but was there any one like particular event or instance that really stands out in your experience that you never thought that you would experience as an engineer?
I tell this story, or I've told it a couple of times. I do work at national lab user facilities for where we use, X-rays and neutrons to probe the structures of rocks and image rocks. And I'll never forget actually the first time that I showed up at an X-ray synchrotron facility. I was a PhD student. I think I was in my second year. I knew the science behind it. I knew, kind of what we were doing, but I was not prepared to be fully immersed in kind of the environment of that level of, experimental, science. And, you quite literally walk into this building and stuff's covered in foil, and, people are running from experiment bay to experiment bay because things are happening so fast. And, you're kind of working all hours of the night because things go 24 hours when you're running an expensive, set of experiments. And so, the sort of thrill of, having to get up at 4 a.m. and check on my experiments and, then come back the next morning. And, that was an experience that I was not, it was sort of the first time in my life that I thought, wow, this is science. I've made it. I can look around me and science is happening right now, 24/7. So I think that's the first time for me. So it stands out for me that was the first time that, I was sort of immersed in, science in that way.
Yeah. And then with that, a lot of the time it's hard for the public to really understand what being a scientist means, I guess. And they don't have that experience that you have of like actually doing experiments and being in the lab. So what part of your work do you think pertains to the public or coincides with public interests? Something that like maybe society can grasp onto even if they've never been a scientist before?
Yeah, so recently my work has shifted towards, more towards thinking about how the chemical interactions between water and rock contribute to stream water quality. And so really looking at, what controls, the chemistry of streams in our watersheds, in our mountainous watersheds. We've done work looking at the impact of, pine tree death because of mountain pine beetles. And so really looking at how the death of pine trees propagate through watershed processes and then change the water chemistry, coming out of that watershed. We're starting to think about, how long-term climate change is going to change water quality, and really starting to try to understand, how a watershed works so that we can try to be more predictive about, what water quality is going to look like in the future, either under, future climate scenarios or even under future land use. So we live at the sort of urban wildland fringe, and so as land use changes and urban growth expands into wildlands, the more we can understand about how a watershed works, and how the rocks and the water interact together, then we're better able to predict changes into the future. And so so we have a component of the work now that's really trying to understand how water moves through a watershed, and then along the way picks up solutes, picks up a chemistry that's got a signal or a signature of the chemical reactions that water has driven as it moves through a watershed. And then we use numerical models to really test hypotheses and try to generate models that can be predictive into the future. So we're constraining the kinds of information that we need to make these models and have confidence in their ability to predict behavior under changing conditions.
Yeah, that's really interesting. And then maybe in like the context of climate change and land use, like you just mentioned, which aspects of geochemistry would you say are human-centered and why?
Yeah, that's a good question. I mean, I think for me, it boils down really to the fact that, we need geochemistry to create a landscape that is habitable. And so if rocks don't weather, then we don't make soil. So if geochemistry doesn't happen, then soil doesn't happen. And I work in an area of science that it's called critical zone science, where we're really thinking about, again, how do watersheds operate? How does the near surface work? From the tops of the trees down to groundwater, which is the area that we call the critical zone, because we want to understand how that zone forms. How does rock turn into soil? What controls, how much soil we get? How fast does it happen? What does that soil look like? What controls how much water do we store in these subsurface environments for plants to be able to draw on during dry periods? How does microclimate and microtopography, control soil processes and weathering? And so really it's human-centered in the sense that, we live on this landscape, and this landscape is sculpted by geologic processes. So.
Yeah. And so we did a little research, and we know that you have a research grant for community-based educational infrastructure for numerical simulation in the earth sciences. It's a mouthful, but we kind of caught on to that community-based part of it. And so we were just wondering if you could tell us a little bit more about that project.
Yeah, for sure. So that project is really, so, I said we use numerical models to try to test hypotheses and to really test our understanding of how systems work. And these models couple equations for hydrology, so equations for fluid flow to be able to, calculate, things that are related to how water moves through rocks and soils. And then the equations that we use for geochemistry. So how fast do geochemical reactions happen? What geochemical reactions happen? What's the product of those reactions in terms of, water chemistry? And so we couple those two sets of equations together. And the coupling of those two sets of models is actually relatively new in the science landscape. So, in the last 20 years or so. And with the coupling and then, all of the advances that have been made in advanced computing, so algorithms and, data management and high performance computing, the computational ability of these codes really took off in a way that training to use those codes hasn't kept pace. And so there's all these really powerful codes out there, but there's a pretty small subset of people that use them in their science, even though they're powerful. And so we were funded, myself and two collaborators were funded by the National Science Foundation to really work with the community of people that use these codes to get a better training system in place, to really think about how do we train students and researchers to think about systems in a way that we can use numerical models and we can apply numerical models to them to better understand how they operate. And so it's community-based in the sense that we're drawing on the community expertise of people who, build these codes and people who use these codes. But then it's community based also in the sense that we're trying to create a community of people who apply these codes on a regular basis, who have the training and the expertise, and really know how the codes work. It's been an interesting project for me because we're really drawing on a lot of design education. So we're looking at how do you train people in areas of design, which is really how do you train people to think about a problem. And so we can train people, we can show people what the input files look like, and we can show people okay, these are the equations that are being solved, and this is the button that you push to make the model go, and these are the kinds of plots that you can make. But what it really boils down to is that you have to train people how to think differently about a problem in order for the model and the conceptual model and the numerical model to be linked to each other. And so you've got to take the natural system and convert it to a conceptual model, and then take the conceptual model and convert it to a numerical model. And so it's really that design process that goes, loops around this, here's the real system, here's our conceptual system that's simplified, and then here's our numerical system where we solve all the equations, and then we go back the other direction and, try to better understand, what don't we understand about the system? Is there some piece that we're missing? Is the math wrong? How do we work through this, design problem to better understand our science, basically. So that's the the intent of that project.
Yeah, that's super interesting. And I was kind of wondering, because you were saying you have to think differently as the engineer, the scientist. Do you think that is being taught, like that way of thinking differently is being taught in the engineering classes, or is that something that you kind of have to work with your research assistants on and such?
Yeah, so I mean, I definitely see it in in our classes, where we talk about processes and assumptions and really thinking through conceptually, how does a system work. I think the piece that that we're really trying to focus on is that translation of a conceptual model to a numerical model. We've been calling it deliberate communication, and so we need to be deliberate in our communication, between what we're telling the model to do, meaning that you need to know what it's doing. And then you need to be deliberate in the communication between the conceptual model and the numerical model, to make sure that those two are linked in a way that they're basically representative of the same thing. And so yeah, I think that for us, the design education and the design pedagogy lends itself really, really well to be able to adapt that for this linkage between conceptual model and numerical model.
So to take a pause from that, I'm going to ask a question that Kevin Moore brought up in the chat. He mentions the prevalence of permaculture community restoration ecology, which includes soil regeneration. And he asked if you're aware of geochemists working in this area. And he mentions that they seem to know, or what they seem to know would help inform what's possible in a given location.
I don't know anyone that's actually working in sort of a soil regeneration, landscape. I know quite a few people who are working in, a better understanding of, the chemistry of agricultural soils, and, using the chemistry, localized chemistry and localized hydrology to better manage fertilizer application or amendment application, so soil amendments. And so being really careful about, amending soil in a way that makes sense for that soil instead of sort of, blanket application. But I don't know anyone that's working in soil regeneration. That would be an interesting area to look at.
Yeah. So in your opinion, this is kind of going off on a different track, but we were wondering what you thought about how engineers are accountable to the public.
Yeah, I mean, I guess I would answer that by saying that, we're accountable to the public because we have a specialized knowledge, right? And, our goal is to really apply that knowledge, to to solve problems and, to come up with solutions that, help address, some issues. And so, I think accountable to versus, the responsibility that we have might be a little bit different, right? So I feel like we have a responsibility to, to use our knowledge and to use, our skill sets from being trained, to, to help identify and solve problems. In terms of accountability, that probably goes into an area of space that's, more on, policy and things, and that I'm not really equipped to discuss very well.
So you mentioned just now, like, the difference between accountability and responsibility of engineers and scientists. Would you say that, like, that works towards more responsible engineering, or kind of is it's counterproductive towards it?
Meaning that there is an accountability structure? Is that?
Yeah, I guess, like, the difference between what engineers are accountable for and what engineers are responsible for.
I see. I think that there are definitely some interesting there's some interesting issues in this space. And something that comes up for me is it wasn't too long ago that I think it was some Spanish scientists that worked for the government, failed to predict, some volcanic activity, and were held personally responsible for that. And that, to me, I think that, while we have a responsibility to use our knowledge and to the best of our abilities, on the accountability side, I think that we have to think about, what can we truly be held accountable for? Can we be held accountable for, not, sort of not seeing a connection, that would have, prevented something if it's not specifically in your training, right? And so that's where I guess the line between accountability and responsibility, falls for me, is that, when we're talking about accountability, there's really, has to be a sort of a defined set of parameters against which that's measured, and it needs to be communicated, and people need to be, people need to know what they're going to be held accountable for. Whereas responsibility, I think, is more of a, it's more of a personal feeling, right? And that, you feel a sense of responsibility to yourself and to, society, to be able to, work to solve problems. Then you're going to bring your best, work to that. But then I feel like if people are going to be, if people know they're going to be held accountable, they may, not broach certain subjects, basically, because they may feel like, well, I don't know this exactly, and so I'm just not going to say anything to avoid, some of those accountability issues. So I feel like that's, for me, where accountability and responsibility deviate a little bit, and that's the one case, I think that, no volcanologist can predict, volcanic activity at this point. That's just not something that's, reasonable expectation. So accountability needs to be based on reasonable expectations. And so, whereas responsibility, I feel like, is a different thing.
Yeah, definitely. I think that's a really interesting way to look at it. It kind of helps me separate accountability and responsibility in my head as well. And so with the examples you just said, and as well as your work with climate change, it seems like the accountability and the responsibility kind of are centered around safety. So engineers should be accountable and should be responsible to try and, keep the safety of the public or wildlife or the environment. Do you think that there is anywhere that you've seen where accountability and responsibility for engineers kind of goes beyond safety? Or is it mostly centered around like public health and safety?
That's an interesting question. I mean, I come out of, because I study water quality, right? And so, I don't really work in systems where, we're thinking about like, acute toxicity or any, sort of acute safety aspect of water quality. We're looking at things that are, less, I guess less acute is probably the way to put it. We're looking more at things like, if water quality changes enough that you need to start to manage water treatment differently. So one of the things that a project that we're trying to get started right now is actually looking at the behavior of phosphorus post wildfire. So as we all know, we had a massive wildfire season in the Western U.S. and I have a collaborator at Mines who studied water quality post wildfire, and a number of years ago she noticed a trend where there was an increase in phosphorus concentrations post wildfire, but it was years later. It was kind of this prolonged impact. And so, in looking into what might cause that, the retardant that's dropped for, to try to prevent the spread of wildfires contains quite a bit of phosphorus. And so there's an application of phosphorus to the landscape during a wildfire. And so we have, I have another collaborator from the USGS who actually is, moving to Mines as research faculty. He's retiring from the USGS. He's kind of transitional, who has sampled a lot of surface waters in the area of the East Troublesome Fire in the past. And so he has previous data. And so we got really interested looking at the samples that he has. He actually has samples that are just outside the wildfire and just inside the wildfire boundary. And so, the questions that we're asking are things like, how does wildfire impact water quality over the long time frame? How long does this perturbation last? What are the, the chemicals that, we can reasonably expect to be, increased concentration post wildfire? And then, from a safety perspective, or maybe not safety, but from a societal perspective, what do water managers need to know about that? Do they need to change the way that they treat water? Do they need to think about how to add in additional filtration in order to manage, the impacts of wildfire? And so they're really interested in organic carbon post wildfire. So we're working with, a couple of water districts and a couple of community community groups that monitor water quality, trying to get some funding in place so that we can actually start sampling and get a project off the ground. And so, I think in the sense of, safety and responsibility and accountability, I think this is still a case where we have a responsibility to try to understand what the impacts are. But it doesn't necessarily, lend itself to, worrying about like acute safety. These aren't chemicals that are, really going to be, something that is going to be, a public health issue, from a safety standpoint. But it's certainly going to be, something that's going to impact potentially, the way the water supplies are treated, how they're managed. And what the lifespan of that, what that perturbation is. And so there's a responsibility, I think, there to provide information and to work with those groups in order to provide them the best possible information we can so that they can manage that within, their operations and then provide clean drinking water. So,
yeah, so like the work that you just described, as well as your like simulation or numerical models with climate change, do you think that like all concerns should be treated equally, like the environment, the public, water, and you know, what if one community or like aspect of those benefits, but like what if, sorry, what if one of those benefits more and is negative for another?
Yeah, that's a tough one. You know, in my, you know, sort of my own work and, you know, my own landscape of prioritizing the things that we work on, I get a little bit, I get a little bit stuck in this question about, you know, where should we be putting our efforts, and, you know, sort of what's most important, if you will, right? And so, you know, I certainly think that, you know, talking to stakeholders and really thinking through the full scope of a problem, right? Which is, you know, I work on sort of small pieces of the problem. So if we kind of go back to the, you know, the watershed water quality and think about, you know, perturbations, you know, from a water quality perspective, you know, that the things that we should be working on might not be readily apparent until you kind of do a full life cycle analysis, right? And then really, you know, figure out, you know, what the problems are. And, you know, there's always going to be a cost benefit analysis that has to be done. You know, I work on, you know, sort of the fundamental, you know, research side of things. And, you know, I work on, you know, the impacts of climate change on, you know, on water quality into the future. I don't work directly on addressing climate change. And, you know, part of me, you know, wonders if I should shift gears and do that. You know, but then part of me also thinks that, you know, there are really, really talented, really smart people working on that have been trained. And it would take me, you know, a while to try to shift gears and move into that space. And so I'm going to do the pieces, you know, that I can do, and then, you know, try to, you know, support and encourage and enable, you know, people who are working on the other pieces that I think are important. So yeah, you know, that's a tough question. And you know, I think that, you know, I see it in my own research trying to answer that question. I see it, you know, sort of in the research landscape trying to answer that question, right? I mean, I feel like, you know, there's just so many, you know, places where we need resources and we need to problem solve that, you know, trying to prioritize one over the other, you know, just becomes a really difficult problem. So that probably wasn't a very solid answer.
Yeah, I don't know if any of these questions have like right answers. So I think so far, yeah, you've been doing a great job giving us a lot to think about. So in your work, have you ever had to manage multiple stakeholders who maybe have competing interests or interests that don't necessarily align? Have you ever dealt with a situation like that?
Not in my research life. You know, in my past life, I worked for a couple of consulting companies, and so, you know, I worked for a small consulting company that was consulting for a larger company. I can't, you know, go into lots of details on the issue, you know, but there was definitely, you know, the pull there between, you know, working for a company that had been, you know, hired by a larger company to manage environmental impacts of the work that they were doing. But we were still hired by a company that wanted the project to keep going. And so, you know, there was definitely, you know, there was definitely some, I guess I would say, internal tension, you know, in some of those positions and some of those jobs where, you know, what I wanted to do and what I, you know, thought the intent of what our job was, really turned out to not be the intent of our job. The intent of our job was just make these measurements, make these reports, and all looks good and move on. So, yeah, I've definitely been in that situation.
So maybe like shifting gears or going back to the accountability conversation, how do you think we can best prepare future engineers and scientists to think about the public accountabilities of our work? Like beyond just the technical side, maybe the more societal implication side?
Yeah, I mean, I honestly think that, we prepare people by, talking about these issues, right? That, science, we don't just do science in a vacuum, right? There are societal implications to the science that we do. We're not just, engineers on projects and, without, having a societal aspect to those things. And so I feel like we best prepare people by talking about the fact that these issues are going to come up, and that your work is connected to these bigger these bigger societal issues or bigger corporate company goals, and to have students really think about how to process that and do that ahead of time instead of in the moment, when you find yourself in a position where you're feeling that tension, and so you've got some language, some resources, some something to draw on to help manage the those to help manage those situations instead of kind of just being put into that situation without ever having really thought about it before, without going in thinking like, oh, I'm just going to do the science, right? Or I'm just going to be the engineer on this project, and then really being able to step back and to think about the the impacts. I was a grad student at Penn State when if anybody's from the that area, they might remember when I think it was I-99 was getting built. They cut across the top of and excavated out the top of this ridge. And as they excavated out the top of this ridge, they exposed a ton of pyrite-laden rock. And so, all of a sudden, all this acid rock drainage started to form. And the people working out there saw it, didn't do anything about it. And, at one point they actually took the waste rock from where they had excavated, crushed it all up and made it into road base. And so they crushed all of this pyrite laden rock up and turned it into road base that then they laid a road down on top of. And so now all of this crushed up pyrite is exposed to the atmosphere and water, and it's generating all of this acid. It's actually a pretty interesting case study. And it was, some fresh out of school, person working on the project that finally called it and was like, this is bad. We've got to, we have to do something about it. And so it took one person, right? And that one person basically shut the project down, and it became a multi-year effort to reclaim and to, fix that problem that had been made. And I think the lesson there is that had somebody said something in the beginning, they wouldn't have crushed it up and used it as road base and made the problem 10,000 times worse than it was. And they still deal with it now because, they basically spread pyrite all over. And so there's still active mitigation and cleanup and monitoring efforts associated with that project. And so when we think about, responsibility versus accountability, and safety, right, I think that's a really good case study where, if we talk about those things, right, and we talk about that with our students and they go and find themselves in that position, right, it's not super they at least have something to draw on where they know that somebody else did something similar. And, there's sort of a history there for our students to draw on that, you can say something, and here's something where you can back up saying something by, this case study where somebody not saying something made it way worse than it would have been in the beginning. And so just, stop and fix it and do the right thing, and move on and save a ton of money and a ton of trouble and, all of the, the effects of not stopping and saving it. So I think those are really important things for our students to realize, that this happens. It does happen. And you could be in a position where, you're the person to recognize what's going on and, say something about it.
Yeah, I think that's a great example. And what I think about when you were talking about that was how I feel like I've asked this to a lot of professors and people in industry about how someone new to the industry who maybe is starting out in an entry-level position might just feel like you don't have that much say in things, and therefore your accountability kind of lies with whoever your company has accountability towards, or who they say their accountability is towards. And in that case, it sounded like the fresh out of school engineer felt like their accountability was more towards public safety or environmental safety, and that's what made them speak out. So what would you say about maybe a situation where it's not quite as clear in terms of accountability, and what advice do you have for students who are just going out into industry, who feel like they don't have much say, or they can't make those calls in terms of accountability, maybe for a situation that's not quite as clear as like, this is acid mine drainage?
Yeah. I mean, I think, what I always encourage, students, really anyone, to do is to find people that you work with, find people that, are in your organization, that you trust, that, you think that, they've got good values that align with yours, and then, build a relationship with people so that when something does come up, you have someone trusted to go to. They may be your boss, they may not be your boss. They may be somebody who's just, a couple years senior to you. But I think that there's real value in finding people within, your company or your organization or your team that, you trust, and that, you think that they have the same sense of responsibility that you do. And so that, when you bring something to them, they're gonna see, they're gonna see the issues too, and then help you navigate something. And, I think the other thing is, as I don't know, I even feel this way sometimes, right? I've been out of school for long, right? But, sometimes you can just feel like, the answer to something, you're worried about something, and then you go talk to someone about it and you realize that there are aspects to it that you didn't see, right? And so some of these smaller, maybe something that you're worried about that, it seems to you problematic, but if you're able to talk to someone, that's got a little bit different perspective or has been around for a little bit longer, they might be able to explain, how things are connected in a way that then alleviate, your worries. And so, having someone trusted can really help you, through that. And, it helps you grow, as a professional, and helps you see things in a different way. It helps you get a better understanding of, what are the important things that, where I do want to stand up and say something, and I'm willing to, stand up and push back on something, versus the places that, maybe you don't stand up and push back, but you seek out, people to talk to get a better idea of the full scope of the situation before you kind of, put yourself out there like that. So.
Yeah, I think that's a really good point. And then maybe even building off of Cassidy's question, you mentioned the situation with the pyrite and how a junior level engineer like finally spoke up. Would you say that your loyalty changes as as you spend more time with like one company? Do you think your loyalty ever changes? Like, do you feel more loyal to the company or more loyal to the public? Do you think it changes with time?
I don't know. I would venture to say that is going to be highly individualized, both individual companies and, individual people. I have worked, short stints in companies. I've, not spent, even what I would consider a portion of a career really, working for a company. I have, a little bit of, front seat view of it from, my family. And I do think that, the first couple of years working somewhere is really figuring out, what's the culture, what are the values, how do I fit into this organization, right? And then you can kind of, once you understand that, and it's a good fit and you can see a career there, then you can really start to move into a space where you think about, okay, now how do I contribute to, this culture, and how do I contribute to these values? And if there are places where, you think that it's not, quite the right, quite the right path, then, you've got the time in the company, you've developed the relationships, these trusted relationships with people, you have a different perspective, a bigger picture perspective, and then you can kind of start to work from within a little bit to change things if you want to. So I think it's going to be highly individualized. I think, companies and individuals and people change. And, that's just going to be an evolving relationship, no matter who you are or where you work.
Yeah, that's a really good point. And then maybe shifting gears, and this is a very open-ended question, but how might you define good engineering from your field of expertise in geochemistry? Very open-ended.
Yeah. That's a great question. I mean, I kind of want to go back to this idea of, sort of design principles, right? And really, I think for me, good engineering, good science, is really getting your head around the scope of the problem that you're trying to address, or the question that you're trying to answer. And really thinking about it from different angles, really, looking at, the problem from different viewpoints, and then, bringing expertise to that, whether that's your expertise. I mean, we all have expertise to lend to that. But if you're looking at something, a problem, or a design problem or something, from a certain viewpoint, and you bring in other expertise, right? You ask people with the expertise, to help you work through, what are the issues at hand here, and really, being open-minded to, what you come across, and, really constantly evaluating, what are the questions that I'm asking? Are those still the appropriate questions? We always start down these paths with questions or hypotheses or, ideas of how a system works. And then as you learn more, evaluating those as you go, and making sure that you're still asking the right questions, or you're still, testing, the relevant hypothesis, and really being open-minded from start to finish is I think, the hallmark really of good work.
Sorry, go ahead, Cassie.
Good. So do you have any specific examples that you can think of that you might define as good engineering? It's okay if not as well.
Yeah. I mean, I kind of come back to it as the design process. I'm not, I'm actually not a trained engineer. I work with a lot of engineers, and so, I'm sort of substituting science in for engineering here a little bit. And so, yeah, I don't, I mean, I think in terms of specific examples, nothing comes right off the top of my head that's a good, sort of illustration. But again, just this idea of really thinking through the problem from start to finish, right? And really, I think for me sometimes, I know that that's happening when I have a moment or, something that happens in, in a project where I'm sort of floored a little bit by our results, right? And like we get something that doesn't make sense and we keep trying to kind of put it in a box, and then you realize that you have to throw the box away because it's not going to fit in that box, right? And you need to like find a basket instead or something, right? Like, and so you kind of have to like, I feel like in almost every project I've taken on, there is a point in that project that's almost like an aha moment where I have to go back and really question my assumptions or question my preconceived notion about, what we were going to find, or, how this system was going to work, or the mechanisms that we thought were controlling things. And that's when I know that it's good science. And that's when I know that it's a good project. And so, I feel like for me, that's the piece of it. I think I just gave Dean a new motto.
Yes, you did. So then I guess building off of this, like this definition or like examples of good engineering, as well as like responsibility and accountability, how do you think you'll integrate these themes into your work with the Ben Freer, I'm sure I'm saying that name wrong, chair with your with your award?
Yeah, that's a good question. So, the project that I'm taking on there is really, about looking at the faculty experience at mines, and how we can use faculty excitement and the really the creativity of faculty, and how we can harness that basically to just make mines better, right? And so how can we enable faculty to work on things that they're passionate about, and that they want to dive into, and how can we connect them to projects on campus and initiatives on campus that align with the things that they want to do, and to do it in a way that's intentional, in a way that faculty think through, these are the things that are important to me. This is what I would love to see happen over the next 3 or 4 years. And then, how do we make that happen in a way that benefits mines, right? And so we're going to take, and really try to make connections between, faculty who are serving mines in a service role and making mines a better place. And so I think for me, what that really boils down to is, from a university perspective, right, from an employer perspective, we want mines to be the best place to work, right? Like we want mines to be an amazing place to work. And if we can be intentional about, connecting, faculty on their path and really creating a vision for them in a career at mines that connects them to the community and, makes them, be a part of the changes that are happening on campus, then, that benefits mines, but it also, it benefits our faculty too. And so, in terms of the sense of responsibility, part of that came out of me feeling a sense of responsibility, to put myself out there and propose this program, because it was something that I wanted. I wanted to sit down and think about, how does my career connect with mines in the next, 5-10 years? How do I make that happen? And what are the opportunities on campus? And it actually goes back a little bit to what we were talking about in terms of like prioritizing things, right? There were so many places that I wanted to, that I wanted to be involved in what was happening on campus, that I almost suffered a little bit of a paralysis because I didn't know where to go and which one, to connect to. And so, I realized that I needed to sit down and think about my values and my path and my, what I wanted, and then find the things on campus that allowed me to work in that space, which then allowed me to really narrow the opportunities and the things that I wanted to do. The nice thing about that is it allows me to to turn down some opportunities in spaces and be really comfortable with it. Because I just know it's not something that is, I'm going to be excited about. It's not something that I'm going to, put my everything into, and mine isn't going to get the best of me because it's not something that I'm really passionate about doing. And so I want to, I feel a sense of responsibility to kind of create that for other faculty on campus, because, I think we all are busy and we all kind of have these spaces and, this passion about certain things, but maybe don't know how to connect to it, or don't, haven't gone through the thought process really of, connecting our values to the things that we want to do and the ways that we're going to be passionate on campus. And so that's really, kind of where I came to, this proposal for the Freyer chair. That's where I came at that, idea. And so I'm really excited. I hope other faculty, want to take this journey with me and, really think about, their careers and how it connects to campus. And so I'm hopeful that I can be motivating in that way and, really create something that, that faculty feel is important and that, they think, is beneficial for them.
Yeah, that's great. And congratulations again on that award. So in the last few minutes, we have a couple questions from the audience. So the first one is from Dean. He asks if you could make one fundamental change to Mine's undergraduate education, free of all committees, approvals, and departmental politics, what would it be? And since you kind of answered this a little bit with your proposal, but maybe in terms of like a bigger picture, something that you don't necessarily have to head up, but still a change that you'd like to see.
Yeah, man, I'm gonna probably be a little idealistic here. What the one thing that always stands out to me about Mine students is that I kind of feel like, maybe 70% of my job is to get them excited about the topic and then get out of their way a little bit, right? And so, I think that, the other 30% of my job is connecting them to resources that help them. And so, if we could figure out a way, right, that every student at Mines, was basically a self-learner, right? That, we were here to motivate and point along a path and, be a sounding block, provide expertise, provide connections, to things, but then really let, students drive a good portion of what they do on campus. I think that would be amazing. I would love to be a part of something like that, I do it like, miniature scale in my classes to some extent where I can, where I can kind of create opportunities for students to, to find aspects of what we're doing in class that they're interested in and they want to dive into. And I feel like every time I do that, my expectations are just blown out of the water, with what students put into and what they come up with, which is awesome. And so, if we could scale that up in some way so that, that kind of experience, students could, do that basically the entire time. I would love to do that. So.
Yeah, that's awesome. That sounds good to me. Yeah, great. So we just have one more question. We might have to be a little quick here, but I believe Juan had a question. If you'd like to ask it, yeah.
Can you hear me?
Yep.
Okay, so apologies for being late. I was in graduate council until 5. This is Juan Lucena, Director of Humanitarian Engineering undergraduate programs. We're trying to create a joint fellowship between our master students in humanitarian engineering, particularly those in the geological engineering and geophysics, with students from Western Colorado University in environmental management. And we want to identify problem areas that are affecting communities in the Rocky Mountain area. problems that humanitarian engineering students, again, with an emphasis in geological engineering, and environmental management students can tackle together. We spoke of acid drainage from abandoned mines, so that's clearly one. Could you help us from your experience to find if you have any of your favorite problem areas that you see in this area of the world affecting communities where our students in humanitarian engineering and their students in environmental management could work together?
That is a great question. I think for me, the thing that stands out and has become an increasing issue in Colorado, and I think in some degrees in the West in general, is really damage to sensitive landscapes. There are so many people in the backcountry now, and I like I said, I grew up in Moab. I grew up with the motto of "Don't bust the crust." so cryptobiotic soil in the desert is really, really important. And it basically, it's a bunch of fungi and bacteria that, create this crust that stabilize the surface, that prevent erosion and allow plants to grow. And, and so there was a huge campaign as I was, sort of going through my formative years to educate people not to walk across this stuff. It takes 500 years to grow back. So one footstep, right? And you can see the effects of that for a long time. And I know that, as our higher elevations experience warmer and warmer winters, things are thawing. Those landscapes are becoming even more sensitive. They're not frozen as much during the year. They're, wet and soggy, and, they can be impacted by, ATVs and vehicles and people walking across them. And so, I think, that is something that, that is rooted in, some natural science, because there's the mechanisms of, why these landscapes are sensitive, and what's sort of the natural science aspect behind it. But then there's an environmental management piece of that too, which is really educating, people and creating ways for people to recreate and for people to use the landscapes, in responsible manners, and making sure that there's enough, resources and support and, the kinds of experiences that people want, but while also, trying to limit the impact to smaller areas. So I think that's one space that, I would find, pretty interesting. I think that, this is a pretty specific example, but water resources is another area. So looking at water resources and, how our waters are used from a recreational perspective, but also from, a municipal perspective. So, the one that comes to mind right now is there's a big, Nestle has a water bottling plant in the Arkansas River Valley outside of Salida, and they are currently trying to re-permit bottling that water, and then there's they're trying to renegotiate a lot of the permits around that, and there's quite a bit of discussion in Salida and the Arkansas River Valley around the water resources, and really understanding the impacts of sinking big wells and bottling water and trucking it over to the Front Range to sell. So I think that's another area, with increased population in the mountain towns, increased reliance on the resources, the water resources in the mountains for mountain towns, instead of shuttling a lot of it off to the Front Range and to Denver. I think there are probably some spaces in there, that would be pretty interesting.
Yeah, that's really interesting. I'm excited to see where that goes. And I think with that, we're gonna wrap up the interview now. It is 5:30. So I want to thank Dr. Navarre for coming tonight and leading us in this great and insightful conversation. I'm sure we're all excited to see what great things you do with the Fryer Award. I'd like, and I'd like to thank Cassidy for co-hosting with me tonight. It's a pleasure. And I'd like to thank everyone for coming. Have a great finals week and rest of the semester, and we look forward to seeing you all next semester. Have a great night.